Here's problem number 27, dealing with free fall motion. So our situation is that you're pondering physics one day, jumping on a trampoline, and you leave the surface of the trampoline with an upward velocity of 3 meters per second. Now, before we go solving down for anything, there is a lot we know just by thinking about the motion. So I'm going to draw our trampoline. And then here you are on the trampoline, and you're going to jump. So you're going to go through an upward motion and a downward motion. We know that you leave with an upward velocity of 3 meters per second. Okay, and that's really the only number that we're given about your motion. However, by thinking about the motion as you go up and you go down, we know other numbers. First of all, for the entire path up and the entire path down, you're in free fall motion. So we know your acceleration is a negative 9.8 meters per second squared. Now, about specific locations, up here at the top of the path, as you're moving up, your velocity slows down. At the top of the path, your velocity reaches 0 for just an instant before you start going back down. So the velocity at the top will be equal to 0. Now, over here, when you return to the same location, to the level of the trampoline, this parabolic curve, which is symmetrical because you're returning to the same location, which means that your velocity over here when you return exactly matches the initial velocity, but it's in the opposite direction, negative 3 meters per second. You have also left one location and returned to the same location, so your total displacement from start to finish would be 0. So now, second step in this problem, we have to decide intervals that we're dealing with. We have 3 intervals, from the bottom to the top, from the top to the return, and then the entire interval from the beginning through the end of the return. So on each part of the problem, we're going to have to decide which interval we have enough to know and matches what we're trying to find. Now, part A, find your displacement, time, and velocity for the following locations of the motion. So we want delta y, we want delta t, and we want that final velocity. Our first location is the top of the path. So then at the top of the path, we know, just reiterating what we know, we've got VI is 3 meters per second. At the top of the path, VF would be equal to 0. So we've already found one of the 3 things without any calculation, just by thinking about the situation. We also know the acceleration is a negative 9.8 meters per second squared. Okay, so on this first part, the interval I'm using is from the beginning to the top. Now, finding the other things that we're asked for. Delta y, given those things, we have enough to use the motion equation VF squared is equal to VI squared plus 2a delta y. And so plugging in our values, this would be 0 is equal to 3 meters per second, quantity squared, plus 2 times a negative 9.8 times delta y. If we do our algebra and solve down for delta y, we get a value of 0.46 meters. Now we need to find delta t. Well, with these givens, I can use the motion equation VF is equal to VI plus a delta t, and this is going to give us 0 is equal to 3 meters per second plus a negative 9.8 times delta t, which is going to give us a delta t value equal to 0.31 seconds. Okay, so that's the first part of the question. Now, the second part of the question on part A, okay, is to find the return when we return to the starting point. And we want to find the same things, which we already know some of them. Your delta y is 0 when you return because you've come back to your starting location. Your final velocity would be negative 3 meters per second, and that negative we would interpret and write down as a downward direction. So then the only thing left to find is time. You can calculate the time or you can find it by inspection. If you're going to calculate, you'd go VF is equal to VI plus A delta T. And this would be negative 3 meters per second equals positive 3 meters per second plus a negative 9.8 times your time. And then solve down for that time, and you get a time of 0.62 seconds. You can also get to that time by inspection because you know that it is a parabolic curve and you're going to the same place on the other side. So then the time on the way up should match the time on the way down. And so we could also take this time and double it to get that time over there. Okay. Now, part B. Find the velocity and the displacement at a time of 0.5 seconds. Filling up my screen here, I'm going to need to erase some. So I'm going to leave our original diagram. Now, we want to find, again, on part B, the velocity at 0.5 seconds and the displacement at 0.5 seconds. So then on this interval, roughly at 0.5 seconds, we know it takes 0.31 to get to the top. My interval would go from the beginning to somewhere on the other side of the parabolic curve. So then about this interval, well, we know the time, 0.5 seconds. We know that you are in free fall motion. Acceleration is a negative 9.8 meters per second squared. We know the initial velocity, positive 3 meters per second. Okay, so the velocity we want to calculate here would be the final. So then I can go VF is equal to VI plus A delta T. So this is going to be VF equals positive 3 meters per second plus a negative 9.8 multiplied by our 0.5 seconds. So that's going to give us a final velocity of 1.9 meters downward. Sorry, meters per second downward. Okay, on our delta y value, we can use another motion equation. Let's see, given what we have, I can go delta y equals VI delta t plus 1/2 A delta t squared. And so that's going to give us positive 3 meters per second multiplied by 0.5 seconds plus 1/2 times your negative 9.8 meters per second squared multiplied by 0.5 seconds squared. Do your algebra and solve down for that value. Forgot to calculate this one ahead. Give me a second to do our algebra there. So that's 3 times 0.5 plus 1/2 times negative 9.8 times 0.5 squared. So that's going to give me a delta y of 0.28 meters. It is positive, so that would mean upward or above our starting location. Now you want to sketch the graphs, and I'm going to have to erase again. We'll knock out this part. Sketch the graphs of the following of the motion from when you leave the trampoline until you return to the trampoline. So we want y versus t, v versus t, and a versus t. Okay, before I draw the graphs, I'm going to kind of put some values that we know. Okay, acceleration through the whole motion, up and down, negative 9.8. Initial velocity is a positive 3 meters per second. Final velocity at the end when you return is negative 3 meters per second. And then you're going to start at the trampoline, which is 0, and also return to the trampoline. So I'm going to start with the acceleration graph. I think that one's the easiest one. Your acceleration is the same value throughout the motion, negative 9.8, horizontal line that goes straight across. Now that value tells you your slope over here. Slope of a velocity versus time graph is acceleration. So we need a slope of negative 9.8. So I'm going to start from the initial velocity, and I'm going to go diagonally downward with a constant slope of negative 9.8 down to our final velocity over there of negative 3. So then this part of the motion is the upward movement. This part is the downward movement. And right there where the velocity is equal to 0, that would correspond to the top of the path. Y versus t, we know our motion equation delta y equals vi delta t plus 1/2 a delta t squared, which is the mathematical equation for a parabola. So that's exactly what we're going to have here, is a parabolic curve. So, especially on this problem, there's really a lot you know by thinking about the motion first, because really the only number they gave us was 3. Everything else you had to generate by thinking through the motion. Ponder physics.